Welcome to the CBT program on Suspension and Damping Systems, Part 3. You will learn about the Agility Select function in Vehicle Model Series 205, as well as the active Magic Body Control Suspension and Damping System for Model Series 217 and 222. You can print out the script for your notes. You can open this, just like the glossary and operation notes, at any time using the quick navigation bar on the left-hand side. On average, it should take you roughly 75 minutes to complete the program. Good luck. The first chapter treats the Agility Select function in Model Series 205. First, you'll learn about its task and availability. Then the transmission modes of Agility Select. And the involved vehicle systems and control units will be presented. It should take you about 25 minutes to complete this chapter. Agility Select is a function with which the driver can shape his or her driving experience as desired. The function offers various transmission modes for this purpose that can be selected using the Agility Select switch. Depending on the vehicle equipment, these transmission modes influence basic vehicle systems, like the drive, the suspension, and the steering. In addition, it takes into account the Eco Start-Stop function and the climate control. Agility Select is available for the vehicles of Model Series 205 as a special equipment or in combination with certain equipment packages. Agility Select is available either with manual transmission or with automatic transmission. In combination with the Airmatic air suspension system, Agility Select also sets the suspension. The Agility Select switch is located on the left in the lower control panel. The selected transmission mode is simultaneously indicated in the multifunction display of the instrument cluster and in the larger audio command display, where the parameters for the vehicle systems are also listed. The selection among the 5 transmission modes of Agility Select changes the handling characteristics of the vehicle accordingly. Please click on the designations of the transmission modes to learn more. The Eco transmission mode makes the vehicle particularly economical to drive, especially regarding the use of drive assemblies. In the Sport transmission mode, the vehicle responds altogether more spontaneously, becoming sporty and nimble. The Sports Plus transmission mode gears the vehicle systems, in particular the drive, the suspension, and the steering, to an extremely sporty driving experience. The Comfort transmission mode makes the vehicle well-balanced and comfortable for a modulated driving style. This transmission mode is automatically set when the ignition is turned on after an idle time of over 4 hours. The individual transmission mode allows the driver to customize the vehicle configuration. The parameters of the displayed vehicle systems can be adjusted in a separate menu for this purpose. After the ignition is turned off, the transmission mode last selected is saved for 4 hours. If driving is interrupted for a longer period of time, the comfort transmission mode will be set to the next time the engine starts. The transmission modes of Agility Select specify certain parameters to the different vehicle systems concerned. Please create a complete overview by clicking on the vehicle systems. As you see, the transmission mode, individual, always offers at least 2 parameters for selection. In the concrete case, only 1 parameter per system is set, however. For example, the driver can opt for a sporty drive, with an otherwise comfortable driving mode. Keep in mind also that the functional scope of Agility Select is also determined by the vehicle equipment. In particular, no adaptations of the suspension occur in vehicles without Airmatic. Agility Select influences the vehicle systems through selective measures. Please click on the icons for the descriptions. Given the modified characteristics of the throttle response, the vehicle drive system responds either more indirectly for an economical and comfortable handling, or more directly for sporty and nimble handling. The engine control system considers a correspondingly modified accelerator pedal curve in each case, so that less or more engine power is produced given the same pedal travel. At the same time, the fully integrated transmission control of the automatic transmission adjusts the shift points. In vehicles with manual transmission, an automatic double clutching function is active in the sporty transmission modes that determines and automatically sets the target speed of the engine at the end of a gear change, creating a dynamic shifting experience. Airmatic allows a comfortable or sporty tuning of the suspension. To obtain the desired suspension setting, the adaptive damping can be set as soft or hard. For the sporty tuning, the vehicle level is also lowered. The electric power steering regulates the steering force support according to the vehicle speed. Its control unit can moreover adjust the steering torque so as to yield a sporty or comfortable steering quality. The Eco Start-Stop function automatically turns off the combustion engine when the vehicle stops and then automatically back on for continued driving. This reduces both fuel consumption and exhaust emissions. The Eco Start-Stop function is therefore automatically disabled only in the transmission mode Sport Plus. The climate control and heating systems of the vehicle perform elemental safety and comfort functions. Their operation is a load on the onboard electrical system and the combustion engine, however. In the Eco Transmission mode, for example, the seat heater and rear window heater output is reduced and the cooling of the air conditioning adapted in order to reduce the energy requirement of these systems to a minimum. The Electronic Stability Program Control Unit is the master control unit of Agility Select. Please click on the operating switch for the function to view the signal transmission for the program selection step by step. The control unit of the left lower control panel registers the operations of the Agility Select switch and reports them to the Audio Command Control panel by LIN bus. The Audio Command Control panel relays these pulses through the telematics CAN to the head unit and the audio command display. From the head unit, the information for operating Agility Select proceeds through the HMI CAN bus to the electronic ignition lock control unit. The electronic ignition lock control unit transmits this information on the one hand through the HMI CAN to the instrument cluster, and on the other hand through the chassis FlexRay to the electronic stability program control unit. The latter then specifies the transmission mode to the vehicle's systems, which is indicated simultaneously in the audio command display and in the multifunction display of the instrument cluster. The Electronic Stability Program Control Unit requests the implementation of the selected transmission mode from the concerned control units via the chassis FlexRay. They include the control units of the electric power steering, the airmatic, and the drivetrain. The powertrain control unit relays the request for Agility Select via the engine CAN to the engine control unit, and, if necessary, through the drivetrain CAN to the transmission control unit. At the same time, the request from the electronic ignition lock control unit is transmitted through the interior CAN to the control unit of the climate control. The instructed control units then take into account the programmed parameters for the selected transmission mode, with the engine control unit also controlling the Eco Start-Stop function. Here you can follow the implementation of the transmission modes in a diagram of the control unit network. Please click on a transmission mode and observe how the parameters in the control units change depending on the selection made. In vehicles with Airmatic, the suspension setting can be influenced through Agility Select. The air suspension system consists of 4 air spring bellows and 4 adaptive hydraulic shock absorbers. The control unit of the system regulates the vehicle level via the air volume in the air suspension bellows with the level control valves in the Airmatic valve unit, and controls the damping force through the damping valve units of the shock absorbers. Along this pathway, the Airmatic control unit also sets the suspension for Agility Select. The Airmatic control unit registers the current driving condition with 4 level and 3 body acceleration sensors, as well as through networking with other control units. Please click on these to learn what information they supply to the control system of the Airmatic. The steering column tube module control unit sends the measurement values of the steering wheel angle sensor to the Airmatic control unit. They are analysed in particular for the dynamic adjustment of the adaptive shock absorbers. The powertrain control unit transmits the engine speed signal from the engine control unit. The Airmatic control unit thereby discerns whether the engine is running. This is important insofar as the compressor of the Airmatic generally turns on only when the engine is running. From the Electronic Stability Program Control Unit, the Airmatic control unit receives crucial dynamic handling data on the wheel speeds, the current braking torque, and the status of the brake light switch, as well as the requirements for implementation of the selected Agility Select transmission mode. The Airmatic network in Model Series 205 differs from the previous versions of the system, mainly through use of the chassis FlexRay. This faster data bus optimizes the reaction times of the suspension and damping system accordingly. Which transmission modes comprise Agility Select? Please select the correct answers and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected selection. Which is the master control unit for the Agility Select function? Please click on the correct answer and confirm with OK. Correct. The Electronic Stability Program Control Unit is the master control unit for Agility Select. The second chapter presents the Magic Body Control Suspension and Damping System for Vehicle Model Series 217 and 222. It describes the task and the design, the hydraulic components, and the actuators and sensors of the system. The crosswind assist in vehicles with Magic or active body control significantly differs from the other version and will therefore also be treated. It will take about 25 minutes to complete this section. Magic Body Control is based on the active body control suspension system and thus also includes its advantages. They include the dynamic wheel-specific adaptation of the suspension, automatic level control for load balancing and speed-dependent level adjustment, as well as the options of an elevated vehicle level and a sporty or comfortable suspension setting. Magic Body Control also uses anticipatory road surface recognition with the aid of the stereo camera for even more precise use of the suspension system. Anticipatory road surface recognition with the aid of the stereo camera is known as the road surface scan. The road surface scan supplies an exact representation of the contour or height profile of the road in front of the vehicle. The Active Body Control control unit processes this information together with the sensor data on the current driving conditions and computes the optimal control strategy for counteracting road bumps like dips and long surface undulations. The suspension system thus prepared therefore reacts at the right moment precisely so as to counteract motions of the automotive bodies as far as possible for hitherto unsurpassed ride comfort. The Magic Body Control suspension and damping system arises in particular through the networking of the Active Body Control control unit with the stereo camera. The resulting additional road surface scan function optimizes the use of the hydraulic suspension struts and the continuously variable shock absorbers. Vehicles with Magic Body Control have the same suspension struts as vehicles with Active Body Control. They can be actively adjusted through regulation of the oil quantities in the hydraulic cylinders. Please click on the suspension strut for the front axle to learn more. The suspension struts of Magic Body Control consist of a steel coil spring connected in series with a hydraulic cylinder and an adaptive shock absorber. Changing the oil quantity in the hydraulic cylinder on the one hand adjusts the base point of the steel spring and therefore its spring force. On the other hand, the position and the level of the automotive bodies can then also be adjusted. Please click on the schematically diagrammed hydraulic cylinder for a description of its use in the case of a surface undulation. On driving onto the surface undulation, the oil first flows out of the hydraulic cylinder because of the accelerate upward motion of the wheel, and immediately flows back in on driving downwards as a result of the downward movement of the wheel. The position of the body consequently hardly changes, and therefore also does not oscillate. Wheel vibrations are absorbed by the shock absorbers and reduced. See the next page for further information. The continuously variable shock absorbers of the suspension struts of Magic Body Control dampen the wheel vibrations better than passive shock absorbers because their damping force can be adjusted by actuating the integrated damping valves individually and dynamically. For example, the shock absorbers in the compression stage during the upward motion of wheel are set to be softer on a surface undulation so that no jolting is noticeable during jouncing. On driving down from the surface undulation and afterwards, their damping force is increased again to decelerate the wheel motions and to modulate the wheel vibrations. The integrated damping valves of the continuously variable shock absorbers are located in their respective working pistons. They have a continuously variable valve restrictor for regulating an additional bypass for the hydraulic fluid in the damping valve. Observe the various control states by clicking on the corresponding buttons. When the bypass is open, the oil can flow both through the check valve in the working piston and through the bypass in the damping valve. The shock absorber then becomes softer the larger the set flow area is. When the bypass of the valve restrictor is closed, the oil can flow only through the check valve in the working piston of the shock absorber. The shock absorber is then hard when reacting to excitations. You already know the hydraulic components of active body control from the second part of this program series on suspension and damping systems. The hydraulic components of magic body control are therefore the same. They include the oil reservoir with oil filter, the oil cooler, and the high-pressure pump. In addition, we again have one central reservoir for the front axle and another for the rear axle. The ABC valve unit for the front axle regulates the oil flow to and from the two front hydraulic cylinders, and the rear axle ABC valve unit regulates the oil flow to and from the hydraulic cylinders of the two rear suspension struts. In both valve units, the hydraulic fluid is conducted through multiple filters. Please finally label the components to obtain an overview of the layout of the hydraulic components. This assignment is not correct. Please look at the corrected assignment. As you've noticed, Magic Body Control has a return reservoir. It serves the avoidance of pressure surges and excessive noise development. The Active Body Control control unit controls the use of hydraulic components of Magic Body Control. It monitors the system pressure with the ABC pressure sensor in the front valve unit and regulates this pressure with the intake throttle valve, as well as a switchover valve at the high-pressure pump. Please click on the Active Body Control control unit to learn how it controls the hydraulics of the suspension struts. The Active Body Control control unit distributes the stored hydraulic pressure through the control valves to the four hydraulic cylinders. In doing so, it measures the pressure for each suspension strut with a separate sensor. Please click on the Active Body Control control unit again to learn about the other actuators of the system. The Active Body Control control unit closes the shutoff valves of the suspension struts only when the engine is turned off to prevent a pressure loss in the hydraulic cylinders. The shutoff valves are therefore always open during automotive operation. The Active Body Control control unit controls the use of the shock absorbers with the damping valves. You can again label the different valves and pressure sensors by clicking on them. The Active Body Control control unit registers the level and the motions of the vehicle body with the aid of 4 level sensors, 3 body acceleration sensors, and a lateral acceleration sensor. In addition, the Active Body Control control unit also uses the pressure sensors for the hydraulic cylinders of the suspension struts and the information from other control units for monitoring and assessing the current driving condition. Please click on the Active Body Control control unit to list the most important such information. Through networking with the stereo camera, the Active Body Control control unit is informed about the height profile of the road and the course of the lane. The Electronic Stability Program control unit transmits the wheel speeds, as well as the computed vehicle speed, and the measurement values of the combined yaw rate sensor for longitudinal, lateral, and rotational speeds. The steering column tube module control unit sends the measurement values from the steering wheel angle sensor, namely the steering wheel angle and the steering wheel velocity. These supplemental data optimize the control of the suspension and damping system and support additional functions such as the crosswind assist to be discussed in the following. The crosswind assist is active while moving straight ahead and on slight curves from a driving speed of 80 km per hour. In vehicles with active body control, it counteracts the influence of side wind gusts by selectively bracing the front and rear axles. The vehicle then remains in the intended lane without the driver having to countersteer. The corrective intervention by active body control does not decelerate the vehicle. In contrast, the crosswind assist operates without active body control, by means of a unilateral brake intervention by the Electronic Stability Program. Consequently, the driver experiences only the positive influence of this function in vehicles with active body control. For use of the crosswind assist, active body control can change the oil pressure and the oil quantity in the different hydraulic cylinders of the suspension struts so as to make the wheel load diagonally distributed. This produces a controlled rotational motion of the vehicle, counteracting and therefore compensating for the action of the side wind. The basis of this effect is the design-related toe-in at the front and rear axles. Click on the buttons for the wind direction to follow the corresponding intervention by the crosswind assist. As a reaction to the crosswind from the right, the left front wheel and the right rear wheel are subjected to a greater load, while the two other wheels are relieved. The result is track guidance that steers against the crosswind and cancels its effect. In the case of a crosswind coming from the left, the right front wheel as well as the left rear wheel receive a greater load, and the two other wheels are relieved. The selectively changed track guidance counteracts the effect of the crosswind. Which tasks are performed by the Magic Body Control? Please select the correct answers and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected selection. Where are each of these valves located? Please drag the texts to the correct positions and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected assignment. How many of these sensors does Magic Body Control use? Please select the correct number in each case and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected solution. The third chapter presents the road surface scan. To this end, we describe the tasks and the design of the stereo camera, as well as its function in anticipatory road surface recognition. We also present the networking of the stereo camera with magic body control and the curve inclination function in the curve transmission mode. You'll need about 25 minutes to complete this chapter. The multifunction camera is centered above, behind the windshield, and captures the area in front of the vehicle. It supplies information about the ambient brightness and relevant objects to the vehicle systems networked with it. The multifunction camera is either a mono or a stereo camera. The stereo camera consists of two high-resolution cameras located at 20 centimeters apart in a shared housing. Please click on the stereo camera to learn about the main benefits of this arrangement. The stereo camera can measure the distance to captured objects because it has two independent optical paths that are computed in conjunction with one another. In contrast, the mono camera can estimate the distance to captured objects only by comparing them against the environment. An exact measurement of the road surface is therefore possible only with the stereo camera. The integrated electronics of the stereo camera analyzes the image data of the two cameras for the object recognition and distance measurement. Please click on the Analysis Electronics to find out more. The Analysis Electronics examines the individual pixels as to brightness, color, and gray values, as well as to contrast with the neighboring pixels, yielding outlines, areas, and shapes. With the aid of stored specifications, such as round shape with red circle for a traffic sign, individual objects and their surroundings are identified. Please click on the Analysis Electronics again for a description of the camera data processing. The analysis electronics of the stereo camera computes the spatial coordinates of a captured object relative to the horizontal and vertical axes in order to determine its position, size, and possibly direction of motion. Because of the additional perspective afforded by the second camera, the electronics can also take into account the longitudinal axis and therefore the spatial depth. Comparable to human two-eyed vision, this 3D effect diminishes with increasing distance, because the difference or angle between the two camera perspectives becomes less. Nevertheless, the stereo camera can determine the distance to an identified object within the range of up to 30 meters in front of the vehicle to sufficient precision. Either version of the multifunction camera can be used for the traffic sign assist, the lane keeping assist, and the adaptive high beam assist. Because of the more precise identification of objects and their distances by means of the stereo camera, the driver assistance systems, Distronic Plus with steering assist and stop-and-go pilot, BAS Plus with cross-traffic assist, and pre-safe brake with pedestrian recognition are used only in combination with this camera version. The road surface scan for the Magic Body Control Suspension and Damping system also operates exclusively with a stereo camera. For the road surface scan, the stereo camera computes a three-dimensional representation of the surface profile of the road at a distance of up to 15 meters. To this end, it analyzes the image data of the lane in front of the vehicle about every 60 milliseconds. Because of the forward movement of the vehicle, new stretches of road are being constantly added. And the sections already processed by the camera are measured from perspectives that are continually moving forward. In this way, the result from the road surface scan is constantly refreshed and optimized. The stereo camera sends the measurement results from the road surface scan through the chassis FlexRay to the active body control unit. The active body control unit stores and processes these results so that the captured stretch extends to just below the vehicle and even just behind it. On this basis, it can optimally control the hydraulics of the suspension system and switch the control valves as preparation, so that the suspension struts will react to road bumps precisely when they are encountered by the wheels. If necessary, the vehicle level can then also be raised altogether early, for example, prior to braking thresholds for reducing congestion without this being noticeable to the occupants. Please click on the control unit to see the corresponding control interventions by active body control. Once the stereo camera detects a braking threshold and reports this to the active body control unit, it opens the control valves for the oil feed to all 4 hydraulic cylinders. The generally increased oil amount in the hydraulic cylinders imperceptibly raises the vehicle level until the wheels can roll over the surface undulation without changing the position of the body, with the active body control unit switching over the control valves of the hydraulic cylinder at the right moments. After passing the braking threshold, the control unit opens the control valves for the oil drainage from all 4 hydraulic cylinders until the normal vehicle level is restored. You can start the described control process again by clicking on the active body control unit. Once the stereo camera detects a braking threshold and reports this to the active body control unit, it opens the control valves for the oil feed to all 4 hydraulic cylinders. The generally increased oil amount in the hydraulic cylinders imperceptibly raises the vehicle level until The wheels can roll over the surface undulation without changing the position of the body, with the active body control unit switching over the control valves of the hydraulic cylinder at the right moments. After passing the braking threshold, the road surface scan is active up to a vehicle speed of 130 km per hour, given sufficient visibility. At higher speeds, it is deactivated. The road surface scan is also deactivated when the increased vehicle level, the sport suspension setting, or the dynamic curve inclination function is set. In certain situations, the road surface scan cannot correctly operate. Please click on the drawings for a list of the possible disrupting factors. The road surface scan has limited functionality if the stereo camera is blinded by the sun or by oncoming traffic, or if the surroundings cannot be correctly registered because of unfavorable weather conditions like rain, fog, or snow. The same is true if the windshield is dirty, fogged up, or covered in the area of the camera. If the road is only insufficiently illuminated or reflective because of moisture or road glaze, and if, as with newly spread asphalt or bright concrete slabs, it has no discernible structure, the road surface scan will function only to a limited extent. The road surface scan cannot properly function if the distance to the vehicle in front is too small, since that vehicle will then block the view of the road. In addition, its functioning is impaired on stretches with very narrow curves, and by powerful acceleration and brake applications. For use of the Magic Body Control Suspension and Damping System, the Active Body Control unit is networked with the stereo camera by the chassis FlexRay. The control buttons for setting the vehicle level and the desired suspension setting belong to the Audio Command control panel. Please click on them for a description of the transmission path of the corresponding user input. The operating unit signals the key operations to the command controller unit via the telematics CAN. From there, the control information travels through the HMI CAN to the electronic ignition lock control unit, and from it through the chassis FlexRay to the active body control unit. Please click on the control button for the level adjustment to learn about the further networking of the system. Adjustment of the elevated vehicle level is possible only if the combustion engine is running, since it drives the high-pressure pump for active body control. That's why the active body control unit is informed about the engine running by the engine control unit. The active body control unit is also connected to the instrument cluster through networking with the electronic ignition lock, so that its system and warning messages can be shown in that display. The chassis FlexRay connects the active body control unit not only with the stereo camera, but also with the steering column tube module control unit and the electronic stability program control unit, among other devices. The steering column tube module control unit transmits the signals from the steering wheel angle sensor, and the electronic stability program control unit sends the wheel speeds, including the computed vehicle speed, as well as the measured longitudinal, lateral, and rotational speeds. The active body control unit analyzes this additional dynamic information, especially for use of the crosswind assist and the curve inclination function by Magic Body Control. The dynamic curve inclination function of Magic Body Control increases driving pleasure and comfort, especially on country roads, by reducing lateral forces acting on occupants when driving along curves. To this end, the vehicle body is automatically inclined by up to 2.65 degrees towards the inside of the curve, depending on the radius of the curve and the vehicle's speed, so that the vehicle leans into the curve. Click on the vehicle to learn how the curve inclination function is implemented. When the curve inclination function is active, the active body control unit continually adapts the suspension struts during cornering. To do so, it increases the oil quantity in the hydraulic cylinders on the outer side of the vehicle, while reducing that amount in the hydraulic cylinders on the inner side. The vehicle body then acts against the centrifugal force and noticeably counteracts its effect on the occupants. The curve inclination function can be used dynamically and in an anticipatory way because the active body control unit is also informed by the stereo camera about the course of the road. The system consequently takes into account the road curvature captured by the camera, together with the measured lateral acceleration, in order to detect curves and properly adjust the suspension. The dynamic curve inclination function is turned on by the control button for the suspension setting. It is selected if both indicator lamps of the button go on. The selection is then indicated as the curve transmission mode in the instrument cluster display. The curve inclination function is active in the vehicle's speed range of 40 to 180 km per hour. Outside this vehicle speed range, the active body control acts like the comfort suspension setting. Which of these systems use the stereo camera for their operation? Please select the correct answers and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected selection. Which preconditions must be met for the road surface scan? Please select the correct answers and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected selection. How do the control pulses for switching on the curve inclination function for the active body control unit? Please drag the text to the correct positions and confirm with OK. That's not correct. Please try again. That's not correct. Please look at the corrected sequence.